All right, so you've done it. You, the builder, have poured countless hours into creating this incredible, state-of-the-art AI model. It's a masterpiece, truly. But now comes the hard part, actually making it practical for the real world. But what if the solution was, well, this simple? This quote is the whole idea behind a really powerful technique called model distillation. It's basically mentorship, but for algorithms. And to really get our heads around this, we're going to use a classic analogy: the teacher and the student. In model distillation, these two are our main characters, and figuring out their roles, that's everything. Okay, let's put you in the hot seat. You have this brilliant model, but it is a heavyweight. It's way too big, way too slow, and just too expensive to run on something like a user's phone. So what's the plan? What do you do? Well, this is where our two characters come into play. See, on one side, you've got the teacher model. This is your original beast. It's massive, super accurate, but kind of slow and costly. And on the other side, we've got our goal, the student model. We need this one to be small, lightning fast, and efficient enough to actually use. So, okay, we have our teacher and our student. But how does that knowledge actually get passed down? Let's take a look at how this whole training process works. It's really just this elegant four-step dance. First, you've got your big, fully trained teacher model ready to go. Second, you feed it your data and get its predictions. Third, and this is the magic right here, you train your little student model to copy what the teacher does. And finally, you deploy that lean, mean, efficient student model. Now, here is the really clever bit. The student isn't just learning that the right answer is cat. No, it's learning that the teacher was, say, 90% sure it was a cat, but also thought there was a 3% chance it might be a small dog. It's learning the teacher's reasoning, its confidence, its uncertainty, the whole picture. Researchers call this dark knowledge, and it's all that rich, subtle info that explains why the teacher got to its conclusion. Of course, all this amazing efficiency doesn't just come for free. We've got to talk about the practical side of distillation, and that means facing the trade-offs that every single builder has to think about. And it really boils down to this fundamental compromise. The pros, they're huge. Your model gets so much faster and way cheaper to run. The con is pretty straightforward too. You are probably going to see a small drop in that peak quality. It's all about making a strategic choice. And just look at this. It really shows you how big those pros are. Check out the difference in inference speed. That's how fast the model makes a decision. It's through the roof for the student, all while its size is just massively reduced. I mean, these aren't small adjustments. These are total game changers for deployment. So what about that downside, that loss in quality? Just how much are we talking about here? Well, typically, you're looking at a drop of only around 3% in peak performance. For a ton of applications out there, that's a tiny, tiny price to pay for the huge wins you get in speed and cost. Okay, so the theory is awesome, but where is this stuff actually being used? Out in the real world. Let's connect the dots from this abstract idea to things you probably use every single day. Model distillation is really the secret sauce behind a lot of apps that need to be super responsive. I'm talking about things that run directly on your phone, like those on-device assistants or the real-time camera filters you see on social media. They have to be small and fast, which makes them absolutely perfect for the student-teacher approach. All right, so to wrap all this up, how do you decide if distillation is the right call for your project? Let's distill it all down, pun totally intended, into one final actionable checklist. Here it is. This is the one simple, powerful rule of thumb you need to remember. You use model distillation when your deployment cost and the response speed are more important than squeezing out every last absolute fraction of a percentage point of quality. And this is exactly why it's such a killer option for so many builders. You get this perfect trio of advantages. Your final model is faster for the user, cheaper for you to run, and way smaller to ship. It's a pragmatic solution for a very practical world. So let's just leave you with this one last thought to chew on. We know the student learns to imitate the teacher, but because it's being forced to find a more efficient way to represent that knowledge, could the student actually stumble upon new, maybe even more elegant patterns that the giant teacher model completely missed? What happens when the student really starts to think for itself?